Welcome to Simultaneous Equations Level 3. Pause the video now, have a go at the 3 problems on the screen, and I'll go through them with you shortly. You'll find more practice at this level, plus links to the higher levels, as well as other topics, at the end of this video and on the channel homepage. In problem 1, we're solving 7p plus 3q is equal to 32, and 4p minus 5q is equal to minus 22. Now we want to solve these by eliminating one of the variables, which means we need to either get rid of the p's or get rid of the q's. And in order to do that, we need to have the same number of p's in each equation or the same number of q's, and at the moment we don't. Now if we wanted to look at the p's, we could multiply the 7p in the first equation by 4, and multiply the 4p in the second equation by 7, and we'd have 28 p's in both equations. Alternatively, we could look at the q's and multiply the top equation by 5, and the bottom equation by 3, and we'd have a 15q in the first equation and a minus 15q in the second, and we could eliminate these by adding them, and the choice is ours. For this question I'm going to go with the second option, which is to multiply the first equation by 5 and multiply the second equation by 3 to eliminate the q's. Now looking at the first equation, if we multiply it by 5 we have 7p times 5, which is 35p, plus 3q times 5, which is plus 15q, is equal to 32 times 5, which is 160. Moving on to the second equation, we're going to multiply it by 3, so we have 4p times 3, which is 12p, minus 5q times 3, which is minus 15q, and then on the right, minus 22 times 3, which is minus 66. Now since we're eliminating the q's, and they have different signs, we're going to add them to eliminate, because 15q plus minus 15q is 0. So adding both of these equations together and starting on the p's, we have 35p plus 12p, which gives us 47p. The 15q added to the minus 15q becomes 0, and on the right, 160 added to minus 66 gives us 94. We can now solve this equation to find p, and we can do that by removing the times 47 from in front of the p by dividing by 47 and doing the same on the right. And on the left, the times 47 and the divide by 47 cancel out to leave us with p, and on the right, 94 divided by 47 gives us 2. So p equals 2 is the first part of our solution. To now find the value of q, we need to take this value of p and substitute it into one of the two original equations. And the one at the top looks easier to use because it has a plus in it. So we're going to use 7p plus 3q is equal to 32. Now looking at this, we can substitute p for 2. So it becomes 7 times 2 plus 3q is equal to 32. And since 7 times 2 is 14, we have 14 plus 3q is equal to 32. And we can now solve this. So first on the left, we want to remove the 14, and this is a positive 14. So to remove it, we subtract 14 from the left and do the same on the right. And on the left, the plus 14 and the minus 14 cancel out to leave us with 3q, and on the right, 32 minus 14 gives us 18. Finally, to remove the times 3 in front of the q, we divide by 3 on the left, and we need to do the same on the right. And on the left, the times 3 and the divide by 3 cancel out to leave us with q, and on the right, 18 divided by 3 is 6, so q is equal to 6. And this means that our final solution for problem 1 is p is equal to 2, q is equal to 6. In problem 2, we're solving 5x minus 3y equals 28 and 3x minus 4y equals 19. Now again, to eliminate one of the variables, we need to either have the same number in front of the x's or the same number in front of the y's, and again we don't. So we've got two options. We can multiply the first equation by 3 and the second equation by 5, and this will make the number in front of both x's 15, or we can multiply the first equation by 4 and the second equation by 3, and this makes both numbers in front of y's minus 12, and again the choice is ours. So I'm going to go the first option. I'm going to multiply the top equation by 3 and the bottom equation by 5, which means I'm going to be eliminating the x's. So starting at the top, 5x times 3 is 15x, minus 3y times 3 is minus 9y, and on the right, 28 times 3 gives us 84. Moving on to the second equation, we have 3x times 5 gives us 15x, minus 4y times 5 gives us minus 20y, and on the right, 19 times 5 gives us 95. Now, since we're eliminating the x's, and they're both positive, so they both have the same sign, we're going to subtract, because 15x minus 15x gives us 0. So we know that the 15x's are going to cancel out. So moving on to the y's, we have minus 9y minus 20y. And these two minuses in the middle are equivalent to a plus. So we're actually doing minus 9y plus 20y, which gives us 11y. And on the right, 84 minus 95 gives us minus 11. We can now solve to find y by dividing the left by 11 and doing the same on the right. On the left, the times 11 and the divide by 11 cancel out to leave us with y. And on the right, minus 11 divided by 11 is minus 1. So y equals minus 1 is the first part of our solution. To find the value of x, we now need to take this value of y and substitute it into one of the two original equations. And these two equations are very similar, so it doesn't make a huge difference which one we use, but I'm going to use the second one simply because the numbers are a little bit smaller. So we have 3x minus 4y is equal to 19. If we substitute y for minus 1, we have 3x minus 4 multiplied by minus 1 is equal to 19. And since minus 4 multiplied by minus 1 is positive 4, this becomes 3x plus 4 is equal to 19. We can now solve this by removing the plus 4 from the left, and we do this by subtracting 4 from the left and doing the same on the right. And on the left, the plus 4 and the minus 4 cancel out to leave us with 3x. And on the right, 19 minus 4 is 15. So to finish off, we need to remove the times 3 in front of the x, which we can do by dividing by 3 and doing the same on the right. On the left, the times 3 and the divide by 3 cancel out to leave x. And on the right, 15 divided by 3 is 5. So x is equal to 5. And this means that our final answer to problem 2 is x equals 5, y equals minus 1. In problem 3, we're solving 6a plus 5b equals 23 and 4a plus 3b equals 13. Now again, we'd like to eliminate either the a's or the b's, and we don't have the same number in front of either of those pairs, so we need to make those numbers the same. So looking at the a's, we could multiply the first equation by 4 and the second equation by 6, and we would then have 24a in both equations, so we could eliminate the a's. Alternatively, we could look at the b's, and we could multiply the first equation by 3 and the second equation by 5, and we'd then have 15 b's in both equations, and we could eliminate the b's. So I'm going to go with the first of those options, and I'm going to multiply the first equation by 4 and the second equation by 6. And this means I'm going to be eliminating the a's. So multiplying the first equation by 4, we have 6a times 4, which is 24a, plus 5b times 4, which is plus 20b, is equal to 23 times 4, which gives us 92. Looking at the second equation, 4a multiplied by 6 is 24a, 3b multiplied by 6 gives us plus 18b, and 13 multiplied by 6 gives us 78. Now that we've done that, we can see that our a's match in the two equations, and so we can eliminate them. And since both of these are positive, we can eliminate them by subtracting them, because 24a minus 24a is going to give us 0. So we know that the a's cancel out, so moving on to the b's, 20b minus 18b gives us 2b, and on the right, 92 minus 78 gives us 14. We can now solve this equation by dividing both sides by 2, and on the left, the times 2 and the divide by 2 cancel out to leave us with b, and on the right, 14 divided by 2 is 7, so b equals 7 is the first part of our solution. To now find the value of a, we want to take this value of b and substitute it into one of the original two equations. And again, these look very similar to each other, but I'm going to choose the second one because the numbers are a little bit smaller. So 4a plus 3b equals 13 becomes 4a plus 3 times 7, since b is 7, and that's equal to 13. Now 3 times 7 is 21, so we have 4a plus 21 is equal to 13, and we can now solve this equation to find a. To start, we can remove the plus 21 by subtracting 21 from both sides, and if we do that on the left, the plus 21 and the minus 21 cancel out to leave us with 4a, and on the right, 13 minus 21 gives us minus 8. Finally, we can remove the times 4 from in front of the a, and we do this by dividing by 4 and doing the same on the other side. And on the left, the times 4 and the divide by 4 cancel out to leave us with a. And on the right, minus 8 divided by 4 is minus 2. So a is equal to minus 2. And this means that our final answer to problem 3 is a is equal to minus 2, b is equal to 7.